Hi, this is Ms. Hollenbach, and today we are going to be doing a lab experiment on animal behavior. I have with me today 10 isopods, or 10 pill bugs. You might know these as the sort of roly-poly guys that you can sometimes find in the garden. And what we are going to be observing is their behavior before and after a stimulus. Animals have two main types of behaviors. They have taxis, which is where they will go towards or away from a stimulus, and they also have kinesis, which is just sort of their random moving around, exploring their environment behavior. So what we are going to do today is we are going to observe the pill bugs, and I have two different sort of containers here, but the containers are linked with a little bridge in the middle. The pill bugs have free rein to go wherever they like, and we're just going to observe them for a couple minutes or so to sort of see what their natural behavior is. For example, right now you can kind of see these guys are kind of climbing on each other and flipping over on their back. One over here is sort of riding on the back of another one, and that seems to be their normal behavior. It's important to observe the animals in their natural state without any stimulus to begin with, so that we can learn what's normal and what's not. So that I can see, hey, them riding around on each other, them flipping on their back, that's a completely normal behavior. So we'll just sort of watch them for a little bit to see if anything else pops up. The first stimulus that we are going to observe is going to be kinesis, or their random motion as they just sort of go about their day. I'm going to label one side of the container A and one side of the container B. And we are going to observe them for 10 minutes total, and each minute we are going to use a data sheet here where we count up how many pill bugs are on side A and how many pill bugs are on side B. So to start with, there's 1 inside B, and then 9 of them are inside A. So I know that he moved, but just sort of in a moment, sort of a quick flash, instantaneous measurement, I'll say that there was 1 inside B and 9 of them inside A. So we will count another minute and then retake a measurement. Okay, so it's been a minute and it looks like, all right, I'm going to call that one guy just moved. So I'm going to say that there's 0 in B, and that means that there is 10 of them in A. Minute 3, and it looks like 1 is still in B and 9 of them are still in A. One important thing to notice is that as we're going through this, it's not always the same one that's in B. There's at least a couple of them that kind of seem to keep switching and moving around. So even though it looks like the data hasn't really changed, some of the pill bugs at least are kind of migrating around. It's just that we only kind of keep catching 1 in B. At this point, it's been a couple minutes of the experiment, and I really want to just sort of like poke these guys and kind of get them to move around, but that would be really bad science. It's important to make sure that we're not disturbing them in any way, and we are just observing them to see their normal behavior. To minute 10, I'm going to say that that guy was inside B, so 2 in B and 8 in A. And that concludes our sort of baseline observations where we're just watching their kinesis and their sort of randomized behavior. Now we are going to attempt to have them react to a stimulus, chemotaxis, where I'm going to place an acid in one side and a base in another side and see which one they prefer. And at this point, if you were to be doing the experiment, or at home if you want to play along, you can make a hypothesis or a guess about what you think they will prefer. If you think that they will prefer to be on the acid side, the base side, or if you don't think there's going to be any changes in behavior. I have some filter paper here where I'm going to place it into each of the little containers. And I'm going to put a few drops of a base potassium hydroxide. Bases are generally things that kind of have a soapy feel to them. And the couple drops that I'm going to be placing, they're not going to harm the animals in any way. As a general rule in experiments, we don't want to cause harm to our animals. We just sort of want to stimulate them to change their normal behavior. And then to these poor guys in A here, I'm going to disturb them. And I'm going to make sure that this guy here doesn't crawl under. That's no good. There you go. I'm going to disturb these guys in A. And then I'm going to place the acid into that container. My acid here is going to be hydrochloric acid. And again, it's a fairly weak acid. Acids you might be more familiar with. It's things like lemon juice or cola or tea. Generally, things that are acid kind of taste sour. So I will wet the filter paper with that acid. And I think I got some under the paper, so I'm going to sort of try to coax them out from under the paper. No, don't go under. All right, so we're going to start the experiment again, and this is actually kind of easy. I happen to have A for acid and B for base. It's like I planned it that way. And we are going to monitor and see how many pill bugs are in each. So we'll take this as our initial measurement. I see 5 and 5, and that's a pretty good start. So I will mark that down. All right, after 2 minutes, it looks like there are 4 inside B and 6 inside A, so we haven't lost any yet either. But I'm at least seeing already more of a preference for side B than there was without the acid-based stimulus. Minute 5 is a pretty big minute for these pill bugs. We have 7 inside B and only 3 left over here inside A. Our very last measurement, it looks like 6 remained in part A and 4 remained in B, and they've kind of settled into their pattern. So now we can observe our data and see if our hypothesis was right or not. Looking at our results, it appears when we were just observing the pill bugs' kinesis and just their generalized movement, it looks like they preferred side A. Now that could be for a number of reasons. Maybe they just sort of started in that side and then you saw that kind of pile. And it did seem as the experiment went on both times, like their movement kind of slowed down, where they just kind of liked to stay where they are. So it might have been just side A is where they started and they kind of formed that little pile and they just wanted to stay there. It doesn't necessarily mean that B was inhospitable. They just maybe weren't into exploring at the time. As we got into the experiment where we changed the variables, it looks like they did at least tend to prefer side B. Maybe not a 100% preferral, because it looks like, a couple times they were half and half, 5 and 5. But still, the numbers inside B went up when we added the base as compared to just the normal sort of control situation. So there's a couple of things that we can do just to kind of make sure that we did the experiment right now that we need to sort of validate our data. One of the things I did when I set this up is I set up my pipettes and I labeled them as acid and base to make sure that there wasn't any cross-contamination. So I can sort of double check that. But maybe I want to make sure that I didn't mess up my acid and bases, so I can sort of double check and test and see and make sure that the experiment is what I think it was. So I have a pH testing paper here, and let's see if I can try this. See if I can kind of press it against the filter paper to test the actual paper. Now it's weak enough acid that I'm not going to hurt my hand because, like I said, we actually drink acids, lemon juice, orange juice, soda. Those things are all acidic. So I compare this to my testing paper and I try to match and see what color it is. I'd say that that's a pretty solid 2, which means that this is fairly acidic. So at least this is definitely acid on that side. Let's double check our base side just to see. And I can tell you already the color it's turning means that this is definitely basic. And if I compare this here, I'd say that's maybe a solid 12, maybe a 13, 12 and a half or so, which means that that side was definitely basic. So we at least had our variables right. We can confirm that we did the experiment right, and it's just up to the pill bugs and their behavior and whichever they decided to prefer. One way that we could confirm our data if we wanted to is to repeat the experiment. That would probably involve taking this out, washing it, putting the pill bugs in anew, and kind of going through the whole thing again. We're not going to sit here for hours and hours and watch pill bugs, but if we had different groups doing this, we could confirm the different settings and take different group data and see if there was a commonality among the data. Another experiment that we could do would be to test for phototaxis, which is where we monitor the pill bugs to see if they move towards or away from light. And that would really just involve taking a dark piece of paper, placing it over one of the sections, and then repeating the same experiment and monitoring how many of them are in A and how many of them are in B, and seeing if they prefer light or dark. One last experiment we could do would be to test for hydrotaxis to see if they prefer to move towards or away from water, where we would take one piece of filter paper and wet it and get it very moist and place it in one side of the container and leave the other container dry and see if the pill bugs move towards the water or they like to stay on the dry side. Pill bugs are pretty easy to find, so as springtime comes around, you might be able to gather up some of your own pill bugs and design your own experiment. Anything that doesn't harm them, of course. And I will see you guys later in a different video.